Welcome to our educational channel from class 9th mathematics. The chapter number 7 is indices. So we can call it as even exponents. Two words we can use. So some textbooks you can see the indices word and some you can find out the exponents. Both are same. So let us see the topics in this chapter. First we'll see what is the indices or exponents, introduction part, and the laws of indices, or the basic properties. We have the three important laws in this. I'll explain. Then positive, fractional, negative, and zero indices. How to identify and what are the formulas based on this. And simplification of expressions problems and some solving exponential equations we'll see in this. Right. When you come to this chapter, okay, so the exponent means some raised to the power. So for example, 2 is a number. If you write 3 times same number, 2 into 2 into 2, 2 I wrote 3 times. That means we can write this is 2 to the power 3. That is 2 raised to the power 3. And same way, let us take a is the element. A into a so on, like this up to 10 terms. Up to 10 terms or 10 times. That means we can write this is a to the power 10. So we can read as a raised to the power 10. Same way to any number is raised. Not only instead of only one, if you take combination like 3 into 3 into 3 into 3 4 times into again a into a into a. This we can write in exponential form. That is 3 raised to the power 4 because 3 is 4 times. That means 3 power 4 is 3 multiplied 4 times, not 3 into 4. Remember. Again, a is raised to the power 3. A is 3 times. So 3 power 4 into a to the power 3. So this is the indices, the basic things we'll use. How many number of times, that is the given that you have to make it as base. And here if you see the word, let us say a to the power m, where a is called the base. This is the base. And which is raised, so that is called the power. So a to the power m, a is the base and m is the power, and 2 to the power 3, so 2 is the base, 3 is the power, and 2a power 3, 2a whole to the power 3, so both are not same. Here is 3 is raised to the only to the a is raised to the power 3. Here is completely 2a raised to the power 3. 2a is multiplied 3 times. That means in this case entire 2a is the base and 3 is the power. So that power for which term or which letters, which variable, that is come under the base, right? And let us see some laws of indices now. Laws of indices or laws of exponents. So we have the three important laws in this. The first law, when you come to this first law, is the product law. Product. So when you come to this product law, let us take with variables. A to the power m means a is raised to the power m, and a to the power n, a is raised to the power n. Whenever the bases are equal, then we can add the powers. A to the power m plus n. This is nothing but product law. Let us see the example. Let's say like 2 raised to the power 3. 2 is 3 times. Again 2 is 4 times to the power. So the power is 3 and power is 4. Completely 2 is 3 times and 4 times. That means overall 2 is raised to the power 3 plus 4. That is 7 times. So this is the product law. Whenever the bases are same, only we can add the powers. So when it's a multiplication case, right? And the second law, this is the quotient. Quotient law. So product is multiplication, right? And when you come to this quotient, is a division. That is a to the power m divided by a to the power n. This you can write a to the power m minus n because denominator is also power. You can subtract this. A power m divided by a power n is equals to a to the power numerator power minus denominator power. Remember, first top one minus second one. See the example. A to the power 7 and a is to the power 3. This is nothing but a to the power 7 minus 3. That is a to the power 4, because a 7 times, denominator 3 times. So if 3 cancel, more 4 are there. No, that's why a got to the power 4 it is. Same way, a to the power 3 divided by a to the power 6 it is. Even though we can take a to the power numerator power minus denominator 6. That is a to the power 3 minus 6 is minus 3. So 8 to the power minus 3 is answer. This one. Next we have the third law in this. That is the power. So when we come to this power law, the statement is 8 to the power m. A is raised to the power m. This entire all to the power n again. So we can write a to the power m into n. M is also power for a and n is to the power for am as the base. Then we can make it as a is to the power m into n. Right? See the example. A to the power 3 all to the power 4. This is a to the power 3 into 4. That is a is to the power 12 it is. Even other examples like 2 to the power 4 all to the power minus 2. We can write 2 to the power 4 into minus 2. 2 to the power minus 8 and so on. Any value is given, you can use the same type, like even a to the power minus 2 all to the power 5. This is a to the power minus 2 again all to the power 5. So minus 2 into 5, that is a to the power minus 10. A to the power minus 10 we can write a to the power 1 by a to the power plus 10. Okay, if with the negative power to make it as positive power, you can reciprocal this. A to the power 3 we can write a power minus 3 is a 1 by a power 3. So these are the basic laws to use this indices: product law, quotient law and power law. So how to handle this positive, fractional, negative and zero indices, we'll see now. Positive, fractional, negative and zero indices. So in this exponents chapter, we need to go through some more formulas or basic concepts in this. For example, a into b whole to the power m, because to solve the problems, numerical sums, we need to do this methods first. So here is a into b whole to the power m. So you can write a to the power m into b to the power m. So that power, which is the number, is raised to the power, no, that we can split to separate each and every term separately when it is into sign. So ab whole power m is a power m into b power m. Remember this. And similarly, even division, like a divided by b whole to the power m. So that is a to the power m by b to the power m. Right. So this is the method. So for example, let's take 2 into 3 whole to the power 4. So we can write this is 2 to the power 4 into 3 to the power 4. Not only 2, even any number, like 3 into a into b whole to the power 6. We can write this separately: 3 power 6, a to the power 6 and b to the power 6 and so on. Even same way division also, like 2 by 3 whole to the power a. So we can write this 2 to the power a by 3 to the power a, right? And next one, if a is non-zero, one rule: if a is not equal to 0 and n is any positive, so n is the positive, then nth root of a is equals to a to the power 1 by n. Nth root of a is equal to a to the power n 1 by n. Here you see square root of 4. You can write this 4 to the power 1 by 2, or else cube root of 9. So we can write this is 9 to the power 1 by 3. So nth root of a, you can treat as nth. N is in this root value. So nth root of a is equal to a to the power 1 by n. Same way, cube root of 9 is 9 power 1 by 3. And square, generally for square, we will not keep number 2 here. Just only symbol. And cube, fourth root, fifth root only you can use this. Right? Generally square root of 10 is 10 to the power 1 by 2. Or else fifth root of 12 is 12 to the power 1 by 5. Right? Remember this. Next property. A to the power m by n. M divided by n is the raised to the power to the a. That we can write nth root of a to the power m. So generally we can write a to the power m divided by n. That is a to the power m whole to the power 1 by n, right? So 1 by n we just wrote like nth root, same like previous. Now this is if is a to the power 4 by 5. So here denominator is 5. That means fifth root of a to the power 4. We write like this. So this is all we can use in the problems. We'll see one by one. Next one. For any non-zero number a, let us take one property. For any non-zero number a, so a is not equal to 0, then a to the power n, you can write 1 by a to the power minus n. And same way, a to the power minus n is equals to 1 by a to the power plus n. Only the small change, plus becomes minus by doing reciprocal of this value. So if it is a to the power 7, you can write 1 by a to the power minus 7. Or else we have the negative value, a to the power minus 3. To make, if you want to make this negative power to positive power, use this formula, 1 by a to the power plus 3 it is. Right? 2 power minus 3 value we could not find out. So you can write into positive power. That is 1 by 2 power plus 3. So 1 by 2 power 3 is 2 into 2 into 2. That is 8. So 1 by 8 is the value of 2 power minus 3. So this is the values. And same way, other the basic is any number, any non-zero number raised to the power 0 is always equal to 1. That is a to the power 0 is 1. Here is a is non-zero. Any non-zero number raised to the power 0 is always 1. 2 to the power 0 is 1. And so on. Any number, even the fraction like minus 3 by 4 whole to the power 0. That value is nothing but 1. Right? Yeah, the basic values remember. And apart from this, one more note I'll show you. Like if it is minus 8 whole to the power m. This is equals to a to the power plus m when m is even number. M is even. So any negative base to the raised to the power even number is always a to the power even, that number. And minus a whole to the power m is equals to minus a is minus a overall bracket to the power m is only minus a to the power m. That is when m is odd number. Why? Because even number of times if you multiply, will minus becomes plus. Like minus 1 into minus 1 is plus 1, or minus 2 into minus 2. So plus 4 because even numbers. Instead of that, if you take minus 3 into minus 3 into minus 3, this value. Only up to here minus 3 into minus 3 is plus 9. Again into minus 3. So plus into minus minus 9 3 is 27. So odd number of times if you multiply negative sign, you'll get negative. Even number of times if you multiply negative sign, you get the positive. Okay, so these are the properties we'll apply in this problems you'll see now. Simplification of expressions. So in this one, by using this previous exponents formulas, let me show you around 10 problems one by one. Evaluate, that means or simplify 27 to the power minus 1 by 3. So here is the base is 27 and raised to the power negative 1 by 3. Okay, if you observe the denominator is 3 here. So you check 27 you can make 3 to the power 3, right? Whole to the power minus 1 by 3. 27 you can do prime factorization, you get 3 into 3 into 3. Then we can write the step like this, 3 to the power 3 into minus 1 by 3. A power m whole power n. A power m into n formula. Can cancel this 3 that is equals to 3 to the power minus 1, that is 1 by 3. Okay. 1 by 3 is the value of 27 to the power minus 1 by 3. And next one. Question is 9 to the power 3 by 2 minus 3 into 5 to the power 0 minus 1 by 81 to the power minus 1 by 2. This you have to simplify. First step 9. So make the bases must be product of the prime numbers. That means 9 we can write some exponent with the prime number. So 3 square, or else check the denominator is 2. And 9 also we can make it as 3 square. All to the power again 3 by 2 minus 3. 5 to the power 0 is 1 formula minus 1 by 81. 81 9 square. So 1 by 81. 1 by 9 square. All to the power minus 1 by 2 asterisk. Then which are the possibility can cancel? 2 to get cancelled. 3 power 3 is this. Minus 3 into 1 is 3. Again minus. 1 by 9 square is 9 to the power minus 2. All to the power minus 1 by 2 again. Right? So 3 power 3. That means 27. Minus 3 minus. You can cancel 2 to minus 1 into minus 1 is plus 1. So that is 9. 27 minus 3. 24 minus 9. So 15. In this way. Just apply the exponents. Product rule, quotient and power rule you can apply and simplify. See the one more sum. Question is 64 by 125 whole to the power minus 2 by 3. This value again divide by sign. 1 by 256 divided by 625 whole to the power 1 by 4 times, take this side, square root of 25 divided by cube root of 64. This we have to simplify. So in this question, first within the base value, so within the bracket you simplify 64 by 125 and denominator is 3 here, right? So 64 which number cube, 125 also some number cube we can make, that is 64 is 64 value, so we can write just 4 cube and 125 is 5 cube, so we can write 4 by 5 whole power 3 to the power again minus 2 by 3 and divided by 1 divided by, first simplify 256 and this 625. This is the 4, denominator is 4, so 5 power 4 is this and 4 to the power 4. You can write 4 by 5 whole to the power 4, that is 256 by 625. Again whole to the power 1 by 4, that is into 1 by 4 into square root of 25 is 5 and cube root of 64. Square root of 25 is 25 power 1 by 2. Square root of 25. Cube root of 64. 64 is 4 cube. That is 4. 64 you can write 4 cube. Cube root and cube cancel. So 4. And you simplify more. 3 get cancel here. 4 4. 4 by 5 power minus 2. To make this positive, negative power to positive power, you can reciprocal this. So there is 5 by 4 all to the power plus 2. 4 by 5 power minus 2, right? So 5 by 4 power plus 2 and divided by this 4 by 5 you got division, divided by 1 by 4 by 5, that is 5 by 4 and into one more is a 5 by 4 is there. As per the BODMAS rule, first you should do the division part. 5 by 4 whole power 2, so 25 by 16. Whenever you keep the into sign, it will be reciprocal. 5 by 4 becomes 4 by 5 and into 5 by 4 is asterisk. Simplify which is the possibilities are there. 4 5 cancel, 5 5 cancel, and finally got 25 by 16. Write in mixed fraction 1 9 by 16. So use the exponents properties and to solve these ones. And let us see one more question to simplify. 27 to the power 4 by 3 plus 32 all to the power 0.8, even decimal powers, plus 0.8 to the power minus 1. Now to simplify this, first 27 you can write 3 cube all to the power 4 by 3 is there, plus 32 you write 2 to the power 5. Just I am doing exponents for prime factorization method for everything, to the power 0.8. Now you write 8 by 10 into 8 by 10 plus 0.8. You can write 8 divided by 10 all to the power minus 1. Now you can simplify. 3 3 get cancelled. 3 to the power 4 here plus 5 times 1, 5 times 2 is again 2 ones are 2 4. 2 to the power 4 plus 8 by 10. If you write 10 by 8, it will be power 1 it is. So 10 by 8 minus power 1 is becomes plus power 1. Same it is. Simplify. 3 power 4 81, 2 to the power 4 16, 10 by 8 is 1.25, and finally 97 plus 1, so 98.25 will get. Even you can write the problems in divisions also. This is the one method, so we can do same type simplifications, not giving more. Let us see another type of questions here. Question is 1176 is exactly equals to 2 to the power p into 3 to the power q into r to the power 7. So 2, 3, okay, and 7 you can take. It is a 7 to the power p, q and r. Find the numerical values of p, q, r. Then whenever the question is like this, here 2, 3, 7 are the base, right? And this 1176 also you can do prime factorization. First prime number is 2, it's divisible by 2. 2 times 5 is 10, 17, 8 is 16, 1 carry, 8. Again 2 table, 2 2s are 4, 8 9, 4. 2 table, so 1, 4 so 8, 1 carry, 14, 7. Next we'll take this 3, check this. 3 4s are 12, 2 carry, 27 is 9. Again 7 7s are 49, 7 on the 7. Finally 1176 is 2 3 times, so 2 to the power 3 and 3 power 1 and 7 power 2 is exactly equals to 2 power p into 3 power q into 7 to the power r. Whenever the bases are same, you can equate the powers. So therefore p is equal to 3 in the place of p, because 2 is matching this and 3 is this. That means q is equals to 1. Then r is equals to 2. R value is 2. Right? This way you can simplify, and by using PQR, if any value they ask to simplify, you can use this. And in this chapter only one more another type of questions. Let us take the mostly you can notice this type of problems like simplify and getting 1, like a to the power m divided by a to the power n whole to the power m plus n into a to the power n by a to the power l. A to the power n it is n by a to the power l all to the power n plus l, and a to the power l by a power m all to the power l plus m. So show that it is equals to 1. So in this case take LHS first. A power m by a power n. So use the formula a to the power m minus n all to the power again m plus 1 is there, dot means into again a to the power n minus l all to the power n plus l, a to the power l minus m all to the power l plus m. Third formula, right? Here is a power rule. That means a to the power m minus n into m plus n. M plus n. Again a to the power n minus l into n plus l. A to the power l minus m into l plus m. Simplify more. M minus n into m plus n. A plus b into a minus b formula. That is a square minus b square. Studied. So same way m minus n into m plus n is m square minus n square into a to the power n square minus l square, a to the power l square minus m square. And first property, when basis is same, we can add the powers. That is a to the power m square minus n square plus n square minus l square plus and l square minus m square. If you notice this plus m square and this is a minus m square plus l square minus l square, everything cancel. A to the power 0, that is equals to 1 because a is non-zero. So mostly these type of, by changing small terms, we have some different questions also like this. So you can solve in this. So these are basic questions to simplify. Next let us see solving the exponential in equation form. Solving exponential equations. So in this chapter, to find the value of x in this exponential, let us see some problems. Let's start with easy ones first. 9 into 3 to the power x is equals to 27 to the power 2x minus 5. So in this question solve, that means you have to find the value of the x in this, right? There's a problem. So we need to make the base equal for the both sides, or else first you have to simplify. 9 we can write 3 square and this is 3 power x. 27 is 3 power 3, again whole to the power 2x minus 5. So LHS is 3 to the power 2 plus x and RHS 3 to the power 3 into 2x minus 5. Now whenever the bases are same, then equate the powers. So then 2 plus x is equals to 3 into 2x minus 5. This is the formula. When a power m is equals to a power n, then m is equal to n. Whenever the base is same, then equate the powers. So we can simplify this. 2 plus x is equal to 3 2 is 6x minus 3 5 is 15. Take x terms one side and that is 5x. X take that side minus 15. That is equal to 17. Then from this x is equal to 17 divided by 5. 3 2 by 5 in mixed fraction. This is one type. And one more question you see in this same. Square root of 3 by 5 whole to the power 1 minus 2x is equals to, value is given 4 17 by 27. This you have to solve it. So you have to simplify both first. That means 3 by 5 it is asked is. So 3 by 5 whole to the power 1 minus 2x. If you remove the square root, no, that is to the power again 1 by 2 is equals to 4 17 by 27. Mixed fraction converted into improper. That is 125 by 27. You'll get the same base while solving. Now 3 by 5 whole to the power. Multiply the powers. 1 minus 2x by 2. Same way check. Can you make 125 and 27 some power 3 or 3 as 3 and 5 base? Yes, we can make. 125 is 5 cube by 27 is 3 cube. That's nothing but 5 by 3 whole cube. But we need 3 by 5. So what we should take if you do reciprocal? 3 by 5 whole to the power minus 3. 5 by 3 power 3, right? So 3 by 5 whole power minus 3. Now bases are same if you observe. Then equate the powers. Therefore 1 minus 2x by 2 is equals to minus 3. Bases are same. You can equate the powers. So 1 minus 2x is equal to minus 6. Then 2x take right side, minus 6 other side. So it's a minus 6 plus 6, no? So 7 it is. That means x is equal to 7 by 2. It's a 3.5. So this is one type solving. Continue one more sum. Question is solve 2 to the power 2x plus 3 minus 9 into 2 to the power x plus 1 is equal to 0. Let us simplify this first. 2 to the power m power, like a power m plus n, that means a power m into a power n. So 2 to the power 2x into 2 to the power 3, you separate this, minus 9 into 2 to the power x plus 1 is equal to 0. And 2 power 2x, we can write 2 power x whole square into 2 cube is 8, minus 9 into 2 power x plus 1 is equal to 0. Here let 2 to the power x is equal to, take some letter y, because you are getting quadratic equation. If you observe, in the place of 2 power x you can take y, then 8y square, okay, y square into 8, 8y square minus 9y plus 1 is equal to 0. This you have to factorize now. So factorization started, no, 8y square minus, split the middle term, minus 8y minus y plus 1 is equal to 0. Factorization only are doing here. Then take 8y is a common, y minus 1 minus 1 is a common, y minus 1 is equal to 0. Finally you'll get y minus 1 into 8y minus 1 is equal to 0. So y is equal to 1 or y is equals to 1 by 8. But actually y is nothing but 2 power x. So you can take now. Therefore 2 to the power x is equal to 1 or 2 to the power x is equal to 1 by 8. You can solve from this both. Here is 2 power x is 1. So any number power 0 is only 1. So x is equal to 0. Or 2 power x is equals to 2 power minus 3, because 1 by 8 is 2 power minus 3. That means x is equals to minus 3. X is minus 3 or x is equal to 0. This is the solving. And combination of the equations will show one problem. Now the question is, if, see this problem, 2 to the power x is equals to 4 into 2 to the power y, and two equations in this, 9 into 3 to the power x is equal to 3 to the power minus y. So find the value of x and y. Find value of x comma y, you have to solve now. So first one, that is 2 to the power x is equals to 4 into 2 to the power y. From this, the solution part, 2 to the power x is equals to 4, we can write 2 square into 2 to the power y, that's equals 2 to the power 2 plus y. So base is equal, no? So x is equals to 2 plus y. Let be equation 1. And next part, 9 into 3 power x is equal to 3 power minus y. That means 9 we can write 3 square into 3 power x is equal to 3 power minus y. That is 3 power 2 plus x is equal to 3 power minus y. That is 2 plus x is equals to minus y. Equation 2. Now by solving or elimination method 1 and 2, we'll get x and y values. So x is equal to 2 plus y. 2 plus x is equal to minus y. So 1 in equation 2, you substitute now. 2 plus, instead of x, I am writing 2 plus y. In the place of x, you write 2 plus y is equals to minus y. Just to solve this. That is 2y is equals to minus 4. 2 plus 2 is 4. Take right side. Then y is equals to minus 2 we got. Y value minus 2. Y value is substitute in equation 1. So from 1, x is equals to 2 plus y value minus 2. That is 0. So x is equal to 0 and y is equals to minus 2. So anything, the main important thing is in chapter, first you can make the base is same, this last topic. To solving, equate the make equate the bases, then equal the powers. If the powers are equal, then make equate the bases and solve and simplify. So first basic properties, that exponent, product and quotient rule you should know, power rule. Along with that, based on those formulas only, we can simplify in this topic, right? And those are watching the first time, you can subscribe to our channel to solve the content in order, to go through the chapters in order. You can subscribe and continue the, working on this.